everybody. So this is the first video to go along with the new unit on polynomials and quadratics. And it's section 13, which is on polynomials. So polynomials come with their own set of vocabulary. So we need to go over some vocabulary. Some we already know, and some are going to be new. So this is just a reminder of what it means to be a term. A term is a chunk of an expression. They're separated by addition. So if I had to pull the expression that's on the screen apart, the pieces would be 4x to the third, negative 6x squared, 5x, and 8. So it's all the pieces if you were to cut it into chunks, and their respective sign stays with the term. So the numbers in front of the variables are called coefficients. So in the term 4x to the third, 4 is the coefficient on x to the third. And in the term negative 6x squared, negative 6 is the coefficient on x squared. So let's fill in the blank. Therefore, the coefficient on x is, well, what's the number in front of the x term? If I look up here, the x term is 5x, and so 5 is the coefficient. The coefficient on 8 is itself. So the coefficient on a constant term is itself. What's the reason for that? That's because 8 can also be written as 8x to the 0. You can include an x to the 0 next to it because we know that anything to the 0 power is 1. So we're not changing the value of 8. 8 is still a constant because it's just like saying 8 times 1. So that's why it's its own coefficient. So there's some practice problems here. In the expression x minus 6x to the fourth, what's the coefficient on x? Well, let's go to just the regular x term. The coefficient here, I don't see a visible one, but we know that means that there's a 1 in the front. And so the coefficient will be 1. What's the coefficient on the x to the fourth term? Well, the number in front of x to the fourth is negative 6. Remember, the sign stays with the term. In the expression 5 minus v to the third, what's the expression of 5, or the coefficient rather, of 5? The coefficient on a constant, we just talked about that, is itself. So the coefficient is a 5. And what's the coefficient on v to the third? V to the third has negative 1 v to the third, because you can always put that 1 back in there. And so the coefficient is negative 1. We're going to remind ourselves what it means to be like terms. We did this in our expressions section when we were learning algebra, but we're going to learn it again here. Like terms have to have the same exact variables raised to the same exact exponents. And so when you identify that they are in fact like, then you can add them together. So for example, 3pq minus 2pq, those are like terms because they both have pq. So I can just do 3 minus 2 and I would have 1 pq. If I have 2xy squared plus negative xy squared, I still have xy squared. My variables look exactly the same. And so I add 2 and negative 1, and that's how I get a 1 xy squared, or just an xy squared. So now we're going to practice combining like terms. If I have negative 4x to the third plus 6x to the third, first of all, I can identify that they are like terms because I have x to the third and I have x to the third. And I want to add negative 4 plus 6. Negative 4 plus 6 is 2x to the third. If I have 9x to the 6 minus 14x to the 6 plus x to the 6, Remember that the coefficient on x to the 6th is a 1, and so I'm really just adding 9 and negative 14 and 1. So 9 minus 14 is negative 5, and negative 5 plus 1 is negative 4x to the 6th. So that would wind up being negative 4x to the 6th when I combine like terms. The last example, I have 12m squared plus 5m plus 4m squared. Are those all like terms? No, they're not. Only the 2m squared and the 4m squared are like. So I can only add those two together. And that's going to give me 16m squared. And I just have to keep the plus 5m, because there's no other like term to combine it with. And that would be it. So that's just a reminder of what you're looking for like terms. Like terms have to look identical to be able to add them together. Okay, if we keep going down the page, now we get into specifically polynomials. So polynomials are a string. They're strings of terms raised to whole number exponents. Okay, and they're usually written in descending exponent order, which we'll talk about later, meaning the highest down to the lowest. So some examples of polynomials would be 2x minus 4, plain variables raised to positive whole exponents. So we're not talking negative exponents, we're not talking fraction exponents, nothing weird can be happening to the variable. So 3x squared plus 5x minus 6, nothing weird happening to those variables. And then for that long one, nothing weird happening to those variables. So what's not a polynomial then? Anything that doesn't fit in that category. So something that's different is happening to those variables. Here, in this first example, x to the negative 1, that's not a positive whole exponent. So that's not a polynomial. For this one, the x is in the denominator. We know that that means the same thing as having a negative exponent. So that is not a polynomial. If x had been underneath a square root sign, that would not be a polynomial. Let's add a few more examples in here. The square root of x minus 2. That's not a polynomial, okay? X to the 1/2. That's not a polynomial because it has a fractional exponent. So those are some more examples of what's not a polynomial. The degree of a term is the sum of the variable's exponents. So a lot of times we're going to be just dealing with one variable, so we don't have to worry about this very much because it's just going to be the visible exponent. For example, 3x to the 4th, exponent's a 4, so it has a degree of 4. 5x, exponent is a 1, so the degree is going to be a 1. Negative 7 has a degree of 0 because it's just like there's an x to the 0 next to it. We talked about that above. Anytime you have a constant term, it has a 0 exponent on the variable. The only time that this really is needed is when you have multiple variables. If I wanted the degree of something like this, I would have to add those exponents together. And so I'd be adding 2 plus 1 on the y, and that's why I'm getting a degree of 3. The good news is that we don't really have to worry about that in this course. We're going to be talking about basically just one variable, so you can just look for the exponent. The degree of a polynomial overall is the highest degree on any of the terms in the polynomial. So let's look at some examples. If I have 3x to the 4th minus 5x squared plus 6, the degree is 4 because that's the highest exponent that exists on any of those terms. It's the highest degree. If I have 5x plus 7, The x has a power of 1. That is the highest exponent that exists. So that has a degree of 1. The leading coefficient is the number in front of the term with the highest degree. So as soon as you spot that highest exponent, it's going to be that coefficient of that term. That's your leading coefficient. There's 3 basic classifications of polynomials. We have the monomial, the binomial, and the trinomial. Look at the prefixes of these words. Monomial has a prefix mono, which means one, just connect it to the English language. So we're talking about things with one term, anything that's only one chunk. So these are 2 examples, okay? A squared, B squared. It's all connected as one. It's one chunk. Plain old 6, that's one thing, okay? So those are monomials. A binomial, split it apart, binomial, so 2 terms. That's going to be anything that can be broken up into 2 pieces. So negative 9x to the 4th plus 3x squared. These are 2 terms. 3m squared n minus 9mn. 3m squared n is one term, and negative 9mn is another term. A trinomial has 3 terms. Again, the prefix is tri, so you can see these can all be broken up into 3 chunks, 3 pieces. So now let's do some practice. If I have 2x to the 3rd plus 5, what should the degree be? Well, I'm looking for the highest exponent that would exist. So the degree would be 3. What type of polynomial is this? Well, how many terms are there? There are only 2 pieces to this polynomial. And so the classification is a binomial. And let's go one further, even though it's not being asked here. What is the leading coefficient? The leading coefficient here is going to be the number in front of that highest degree. And so the leading coefficient here is going to be 2. Now, the second example is tricky because I have 4xy minus 5xy plus 2xy. Those are all like terms. I'm going to have to combine them first because I can't classify a polynomial if it's not simplified. So I have to combine all of these coefficients. 4 take away 5 is negative 1, and then negative 1 plus 2 is just 1xy, is what this all boils down to. So now that I know that that's 1xy, I can answer the questions. The degree is the sum of those exponents. So the degree here will be 2, because there's an exponent of 1 on the x, there's an exponent of 1 on the y, and I'm adding them together. The classification here, now that I've simplified it, is a monomial, because it came down to only one term. And then if I had to pick out the leading coefficient, it would be a 1, because there's only one coefficient left. Okay. If we continue with this sheet, you can also name the polynomial depending on its degree. So if a polynomial has a degree 0, it's a constant polynomial. If a polynomial has a degree 1, it's linear. We talked about that. That shouldn't be a surprise. If a polynomial of degree 2, and that's what we're going to be working with next, it's called a quadratic. If it's a polynomial of degree 3, it's called a cubic. And if it's any other polynomial, you just call it by its degree. So a degree 4 would be a 4th degree polynomial. There's no other special names. We also want to try to get into the habit of writing our polynomials in descending order. So that means from highest degree down to the lowest degree. When we do that, we can easily pick out the degree and the leading coefficient because they will be leading. They will be in the front. So that's why we want to get into the habit of writing in descending order. So we're going to see examples of that next. With all that in mind, let's fill out this chart together. So I'm given a polynomial and I want to answer the following questions in the chart. Write the polynomial in descending order. Well, this one only has one term, so it's already in descending order. What's the degree on this polynomial? Well, it's just -98. There's no variable there, which means it's just like there's an x to the 0 there, which means the degree is 0. The leading coefficient is itself. The constant term is also itself. And the type is a constant. Let's do the next one. 2x minus 7. Is the polynomial in descending order? Yes, I don't have to do anything with this one either, so I can just leave it. 2x minus 7. The degree of this polynomial, the x has a 1 as an exponent. So the degree here is 1. The leading coefficient, the number in front of the highest exponent term, is a 2. The constant term here, the term that is not changing, that does not have a variable on it, is -7. And the classification, the type, is a linear because it has a degree 1. All right, let's look at the next one. -5z plus 9z squared plus 7. Okay, this one's not in descending order. We're going to have to rearrange first. This should really be 9z squared minus 5z plus 7. I'm going to have to rearrange the highest exponent down to the lowest exponent. Now I can easily pick out the answers to the rest of the questions. The degree will be 2, because that's your highest exponent. The leading coefficient will be 9. The constant term is a 7. And the highest exponent is a 2, so it's classified as a quadratic. The next one doesn't have to be rearranged. It's already in descending order, so I'm not even going to bother to write it here. The degree is going to be a 3, because that's the highest exponent. The leading coefficient is a -2. The constant term is a -1. And this is a cubic, because the highest exponent is a 3. The degree is a 3. And last but not least, this is not written in descending order. So first I have to rearrange. I'm going to write x to the 5th plus 4x squared minus x plus 7. And then answer the questions. The degree will be 5. The leading coefficient will be 1. The constant term will be 7. And because it's a degree of 5, there is no classification. So you would just call this a 5th degree polynomial. So there is no special name there. Okay, let's continue with the sheet. Evaluating a polynomial is something we've already learned how to do. So this is where you remember my mantra, plug in with parentheses. If I give you an expression and I say evaluate when x equals -2, that means everywhere we see x, you're going to plug in -2, and then you can plug it directly into your calculator like that. So because we already learned that, I'm not going to show you that here, but just remember that that is something that we already learned how to do. So next, we're going to talk about operations on polynomials. So we're going to learn about adding and subtracting. So we're going to add polynomials first. What if I wanted to add 3x squared minus 5x plus 2x to the fourth minus 3x to the third plus 7x minus 1? This is actually very familiar also. All we want to do here is simplify and combine like terms. So I just have a plus sign in the middle. Nothing's affecting my first polynomial, so I can copy those terms down. And really nothing is affecting the second polynomial because it's just a plus 1 in the front. So I can remove those parentheses too. So plus 2x to the fourth minus 3x to the third plus 7x minus 1. Now I can combine like terms and make sure to write my answer in descending order. So first, let's identify like terms. This is where you can use different shapes around your like terms. I see that there is a negative 5x and a 7x. Other than that, there's no other sets of like terms here, but I'm going to start with the highest degree. So I'm going to start with 2x to the fourth. As I use a term, there is absolutely no harm in crossing it out. In fact, that's a really good strategy, so you don't have to keep looking at all the terms. The next highest would be a minus 3x to the third. Cross that out. The next highest would be a plus 3x squared. Now I have to combine my x terms, so I'm going to add negative 5 plus 7, and that's going to give me a plus 2x. And now those are done, and then I have my minus 1. And that would be my final answer. I have nothing else that I combine. So addition is really just ignore the parentheses, combine like terms, and always write in descending order. Subtraction is slightly more involved. So let's say we wanted to subtract 2x to the third minus 5x plus 1 minus 4x to the fourth minus 3x squared plus 6x minus 2. Is anything affecting the first polynomial? The answer to that's no. There's nothing affecting the first polynomial. So I can remove those parentheses. However, what's affecting the second polynomial? This negative sign, or this negative 1, if you wanted to put the 1 in, has to be distributed to every term that's inside the second polynomial. So that's going to change all my signs. It's going to give me a negative 4x to the fourth, a positive 3x squared, a negative 6x, and a positive 2. All the signs are going to change. But once I get through the parentheses, now I just look for like terms again. So I do have a couple sets of like terms in this one. I have x's that can go together, and I also have constant terms that can go together. But the rest don't have any like terms. So I'm just going to copy those down. And remember, in descending order. So I'm leading with negative 4x to the fourth, because that's my highest exponent. And then I have plus 2x to the third, because that's my next highest exponent. And then plus 3x squared. And now I can combine the x's. Negative 5x minus 6x is negative 11x. And then I add my 1 plus 2, and I get plus 3. And then that polynomial is my final answer. I can't do anything else with that. And that's pretty much it. That's all the operations for now, adding and subtracting polynomials. We're going to do a whole other video on multiplying polynomials because it's a little bit different of a strategy. So I hope this all made sense. Always contact me if you have any questions. And I hope to hear from you soon. Take care.